My name's Alex. I'm the director of the Digital Society program here at Chatham House. I'm really thrilled that you guys will be joining us today for this discussion around the state of artificial intelligence in 2025. As a reminder, we are, contrary to being at Chatham House, on the record today. And if you are joining us around the world, please do share your thoughts with us on Twitter or Blue Sky using the hashtag CE events. And if you're joining us online, please use the Zoom Q&A function for when we get to questions and answers. Now, the frenzy around AI seems to reach a new high here in the UK with the state visit of Donald Trump and a barrage of new multi-billion-dollar investments in AI announced, new data centers, AI growth zones, investments in UK AI companies, but away from the fancy parties and the fanfare. Another conversation was reaching a fever pitch, and that is the conversation that I'd like us to focus on today. In the same 24 hours that Air Force One landed at Stansted, Elisa Yudkowsky, a known AI researcher, doomsayer, some would say, his new book was released and it didn't pull any punches with the title. If anyone builds this, everyone dies. Again, raising the idea that we are building something. If we carry on down this path, we're heading towards catastrophe, that somehow we are just years away from a technology that's going to be somehow so powerful that it will upend everything we know, for better or for worse, about the world. But that isn't the only story that we are hearing about AI. And at the same time, voices are coming out that suggest that current approaches to AI might be hitting their limits. Voices like American psychologist Gary Marcus, if anyone follows him on Twitter, an indefatigable Twitter warrior, who has been arguing for years that large language models may not be the path towards super intelligence. Even folks like Sam Altman or Mark Zuckerberg or Palantir's Alex Karp have suggested that we might be in a bit of an AI bubble, that we might be, quote, overexcited. So who is right? And is there a third option? One in which the science doesn't change that much, but we keep throwing grist at the mill, more money, more processors, more energy, more time, more training. What happens if the science doesn't change, but we just scale up and up and up? What happens to this technology by, let's say, 2030? And what's going on here really matters. Companies are betting big on AI. There are eye-watering sums of money going into this, and without a sense of where the technology is at today, it is tricky to assess what those bets might be, particularly when countries are betting on things like transforming their economies or revolutionizing their public service, or on AI perhaps conferring some kind of strategic competitive advantage with other countries around the world. Now, we are here this evening to answer that question, to build up to what some people call our situational awareness. What the hell is going on? And I can't think of two better people to have this conversation with this evening. Dr. Serafina Goldfarb-Tarrant is head of safety at Cohere, a machine learning PhD and former research engineer. Simon Biggs is a core researcher at Anthropic, leading work looking ahead to where AI might be in the near future, particularly around whether it can automate tasks. Serafina, let's start with you. It is 6:04 p.m. exactly on October the 2nd, 2025. How should we be thinking about frontier machine learning today?
Yeah. Okay, so I predominantly work on safety, which is all of the things that could potentially go wrong. But that usually is informed by a combination of the capabilities and the deployment context, actually, which I think matter potentially more than other things. Like, I think risks always have to be situated within a deployment context.
And a deployment context here is what?
A deployment context here is like, are you using it to power, your airline? Like most agentic benchmarks that are used nowadays are actually retail and airlines. Mm-hmm. Like the standard agentic benchmark people know to be like, is my model a good agent?
So is my plane going to crash, or am I going to lose a customer?
No, not plane crashing. Autopilot's already pretty good, but that's just physics. Can I change my ticket to Baltimore?
Okay.
Versus, or I should use something, I don't know why I used Maryland, but so that's which actually I think is interesting since that's not always that close to what we're really automating in an enterprise context, but it has a bunch of nice properties of a good benchmark. But yeah, so deployment context is like, are you trying to, well, it could be, are you trying to return an airline ticket or are you driving the plane, I suppose, to use your example. But so like inherent risks and inherent trustworthiness of the AI will be dependent on that context.
So could you help me and understand, on the one hand, we're hearing benchmarks around how you might change your ticket to Maryland, right? That doesn't sound like something that's very complicated or difficult to do. And yet I see reports that AI on other benchmarks is outperforming some of the best mathematicians that are in the world, some of the best coders in the world. How do we square that circle?
Yeah. Yeah, so basically, that's a really good question. And actually, the really simple thing that you're talking about, the airline and shopping benchmark, most models actually are still pretty bad at. I mean, they're like kind of okay, but from a security standpoint or something, their failure rate is, I don't know, the best models get like 70%, which is really not that great if you're like worried about which place you're flying to. I don't think most of you would accept a 30% chance of ending up somewhere else. Yeah. Yeah, so whereas as far as that, it's like, so I think it's basically how constrained the test set is, but also how constrained the humans are in the test set. Mm-hmm. So there's basically this, this is from a cognitive scientist, Molly Crockett, but she frames a lot of things as, she talks about techno-optimism as being partly human pessimism. And so, because you can take, like, for instance, there were a whole bunch of benchmarks on where AI models outperformed researchers like me, mm-hmm. In how good the ideas they could come up with, how many they could come up with in a period of time. But the human was sat in a room, like in front of a computer terminal, writing down research ideas, which is not the way most researchers actually do research. Most researchers do research by being in a room with other people and like asking them about their results and coming up with ideas and other things like that. And so there's this way in which sometimes in order to create like a fair setup, you've constrained the human in a way that's not actually super ecologically valid. And so I think some of that is that. And some amount of it is that a lot of the mathematician, I mean, I think a lot of the mathematician stuff, or like, you know, it was actually quite a long time ago that a lot of these models passed the LSAT.
And an LSAT here meaning?
Like the test for being a lawyer.
Right.
Or to be admitted to law school, I believe that is.
Okay.
You all definitely know way more about law than me. You know, so you basically have two elements there. You have the sort of human pessimism element of that you've constrained the humans so much to be outside of their like embodied world, right, that they can't perform the way they normally would. And then whereas the task of, you know, most people I think who work in rebooking your airline flights do not feel their full human creativity is being realized in that setting. Sure. So I think that particular setting doesn't require that as much, although it still requires more than these models can do on average. Right,
and that's the point I'm making. There's clearly a difference with the state of the art between what you're sort of saying is the constrained environment and the sort of the contact with the real world. A difference between passing an exam versus doing science.
Exactly.
Is that right?
And that's sort of, and that's sort of the fact that like exams are proxy metrics to some extent, right? And proxy metrics are valid to the extent that they predict some real world capability. Yeah. So you hope that an exam for being a lawyer will predict your ability to practice law, even though those two settings are relatively different. And there's an interesting question that's been rising of like, the fact that we've designed these things to be predictive of human capabilities, but humans do not have infinite memory. Humans have not read 5 billion hours of data, generally, no matter how much less you sleep than me. And so there's all these like human capabilities that mean that, for instance, like I think a really good example is the ability to paraphrase is used in a lot of tests as an example of understanding. Like if you say something to me, and then I can repeat it back to you in a different way, you go, great, she understood. Whereas actually language models are basically trained to paraphrase. Like that's what a language model does. Like even very bad language models back like, you know, 10 years ago could do like a pretty good paraphrase because that's fundamentally what the basics of learning language is. And so that's like not a good test for capability in a language model. And so I think there's a really interesting sort of like emerging area for science of like what is a good predictive test for a human is not necessarily a good predictive test for a model.
Fine.
But there's not enough work in that yet.
Simon, I saw you sort of smiling and nodding there. Like, so we seem to have on our available to us online a superintelligence in some respect that can somehow pass, well, that's probably a loaded word, but an incredible intelligence that can answer questions in ways that I would previously, it can pass exams, seems to be able to compete with the world's leading coders, compete with the world's leading scientists in some respects, right? But at the same time is struggling with what sound like some quite basic tasks. How do we square that circle in thinking about the impact that this is going to have on the economy?
Yeah, and thank you, Alex, for having me here. Well, I see essentially what you have. You have a sort of dual world where you have these models, you have these tasks which you can run to full autonomy, and then you have these other tasks where there are moments where they fall over. And
what's an example of a task that we can currently think about as like performing almost fully autonomously with really high success rate?
Yeah. So an example that we have begun to see. So me being on the Frontier Red team, I tend to see I tend to look over the horizon or look into the abyss, depending on what day it is. and one of the things is that one of the things we have been seeing is that people are using this in a cyber offense scenario. And so being able to someone who was not able previously to at scale scam people or look at lots of data on what could make someone vulnerable or respond. They are then using this and seeing, hey, I can actually find a way to at scale find weaknesses in how a person is, maybe their finances or something like that, and be able to find a wedge in there that person would have not been able to do by themselves previously. And this is actually in the real world, and we need to be able to stop these as an AI industry.
And so this idea that there are certain things right now that we can say, so clearly phishing is one of them. I don't know, is machine translation an example of something that these, I mean, I understand from previous conversations that it was pretty good at that, but even before we had these latest breakthroughs, but a task that is sort of automatable. How do we know when something is going to move from the bucket of, we're still going to need a human to do this, take it out of that bucket and into this is all automatable? What is on the cusp of that bucket now as far as you guys can see it?
I really liked what Sophie said, where she said it really matters on the deployment. And it depends on the scenario, like how important is if the model gets it wrong.
Right.
And there are some cases where it's actually quite concerning. And so I would say as the very first low-hanging fruit, you have those ones where it's actually okay if it's got a 90% success rate. And you can actually scale that up.
So what would an example of that be?
Things that allow you to, so a good example that we saw recently is you're able to, if you want to be able to form questions when you're doing, if you wanted to automatically interview all of the people here, I could get Claude to automatically interview all of you. And we could be, while we're having this chat, like Claude could be like asking you questions in the audience, you know, and this could be like quite a nice feature, for example, and that's something that we just personally couldn't do at scale. Well, we require quite a few people, and that could be quite helpful in how this today runs, you know, for example. Yeah. And so, but these sorts of scenarios end up being everywhere when you start looking.
There's an announcement that we had hundreds of billions of dollars of investment being made in UK AI, in data centers, investments being made in UK AI companies. What does that tell us about the UK, as it stands when it comes to the state of this technology? Are we, I understand that America's probably out there first and China's probably out there maybe second or first. I don't know. You tell me. Are we in third place, fourth place? Does it matter? Where are we on from where you're sitting?
Yeah, that's really interesting. It's interesting that you talked about machine translation as well, because the early machine translation was all in the UK and Europe. And I think people who are on the tech side haven't forgotten this, because still, I would say a huge amount of the strongest natural language processing, so language AI, which frequently I was looking at this event and I was like, oh, we're just talking about NLP. Actually, we're talking about only language AI. But whereas like AI used to mean like you could be talking about like logistics, right? Like, am I helping your Amazon delivery truck get to where it's going or something along those lines? But yeah, so people who are on the tech side haven't really forgotten that. I think a lot of other people have, especially because of the dominance of a couple of US AI labs. So as far as like second or third or where the UK is, yeah, I guess it kind of depends on what you're counting by. which isn't that clear of an answer. But I think as far as like a huge amount of the development of NLP is still in the UK and France as far as tech talent. And so everyone has had to expand there very quickly just because cultures work that way. People move there for labs and for universities and stuff like that. And so that's definitely still the case here. I mean, I am in the UK because I moved here for that reason and have been here for some time. Yeah, but as far as like the position in the race, I think if you're trying to count by, I don't know, sort of like the top 10, then the UK is quite clearly in there. If you're trying to count by the top couple, it's less clear, but I think the top couple change really frequently depending on your metric. Like, and I don't mean this to be like, oh, everything is relative, but I mostly mean this to be like, you know, are you talking about, if you're talking about like frequently people who are worried about the, you're all going to die if you build this thing, is like catastrophic capabilities, you're talking about like raw compute, enormous models and stuff like that. I am not in that camp of people, but that is what they are talking about. Whereas if you're talking about, let's say, you know, ability to transform an economy, you're actually talking about probably enterprise usage, which is broadly what I work with. And there's a lot of concerns with enterprise usage where it's sort of like, it doesn't really matter if you're like technically the third best model if you're a lot faster and cheaper. Because people's tolerance to wait 15 seconds for the most powerful model to answer their email query is quite low in practice. I don't know if you guys, any of you guys like remember or any time when, you know, if you've been in a situation when you have bad Wi-Fi, right? Like your tolerance for like loading something is really quite short. And so, so I think it's sort of, it really depends on what metric you're optimizing for as far as how high you are. But I think, I genuinely, like, I am in the UK because I think the UK is pretty good as a player there.
Do you see the UK's prospects in the same way? We are, you know, a punching third, a punching fourth, fifth?
I would certainly say that as time goes on, compute, human talent, and energy are the main pieces of this puzzle.
You described those earlier as bottlenecks.
Yes.
So talent is a bottleneck, energy is a bottleneck.
And the chips.
And the chips themselves.
The hardware. And the actual, and today you could probably think of a data center as a big computer. So like it's the chips and being able to make them all connect. Those are the key bottlenecks. And so certainly when an area has good human talent, that is certainly helpful in this current regime right this very moment. I mean, I personally suspect what I have been seeing is that as each model comes out, the number of tasks that can be fully automatable start going up, and the number of tasks where there is a place where the model falls over goes down. And I have not seen that trend change. And so, you go.
Well, I was going to ask you just on this idea of bottlenecks. Is every country facing the same bottlenecks? Is the UK peculiar in the fact that it faces these bottlenecks on energy, on talent, and on compute?
No, so it's. I mean, these are sort of these are the general bottlenecks where if a country can't meet all three of these, then they're in trouble. So if
how's the UK doing?
I suspect we need a lot more ability to have electricity and compute.
Right.
And I think the world would be in a much better place if those capabilities. I mean, I'm from Australia. I'm a little bit biased. I'd also like Australia to also have those capabilities. But it would be really, really nice if we had some democratic countries that had those in there. And a lot of those.
And sorry, if I can just pick up on this idea of the bottlenecks that might be sort of getting in the way. I really want us to sort of think about this, about frontier AI here. Are they bottlenecks that are going to stop enterprise adoption? Are they the bottlenecks that are going to stop the people in this audience, you know, using these technologies, using these tools? Or are these bottlenecks on research, on advancing this technology into something that is new and exciting and powerful? Where might we feel the bottlenecks? Let's say that the UK doesn't manage to connect its new data centers to the grid fast enough. How will that? What does that look like for the UK?
I mean, I think it's both. So I mean, the UK not connecting its data centers is like a problem for the UK economy, but not necessarily for UK AI labs. Like, I mean, it's nice if we have local data centers, but like people buy data centers everywhere, and there's lots of reasons why they might have to, due to different like laws in different jurisdictions. Like sometimes we make some sorts of training choices. Like we literally will train on a data center in the United States versus in Canada versus somewhere else because of local laws in something like that. Everyone does that. And so like, as in that is a capability everyone has. It might be nice because it might be cheaper, and so that would be non-trivially different, right? It will enable startups. It obviously keeps money more local, which is very good for economies, but I don't think it fundamentally changes sort of like how powerful a UK AI lab has the capability of being. The check that someone's gonna have to write for that is going to be enormous regardless. It would be nice if it were smaller, but it will be enormous, even if it's outside the UK. And then the UK could still have a sovereign model. So I don't think that materially, like, again, I think it has a big impact on the economy. I don't think it has a big impact on the power of the AI model. As far as the actual bottlenecks that I see for like, I think that is a bottleneck for like research power for sure. Compute is a huge bottleneck. Compute and electricity are really the same fundamentally. We're talking about the same thing. Those are big bottlenecks as far as research. I think the bottlenecks that I see for enterprise adoption are pretty different, actually. I think they're more around. I don't think I don't think you can, because compute is just fuel, right? And so it's like if you're trying to make a faster or like better car of some type, you can just shove more rocket fuel into it, and it will go faster. But that might not be super efficient. Or you can change the shape of the car to make it more aerodynamic in a variety of ways, right? And that often is more complicated. So you get a huge amount in our industry right now of just attach a rocket to the back, which is what compute is. And you can't get away from adding fuel. I'm not suggesting we don't need more compute. I most days wish I had more compute, genuinely, because I am usually bottlenecked on that as far as like my team and stuff like that, and my company. But I think there's actually a lot more smart things we could do as far as the shape of the car, as far as adoption, because of the things that we've talked about that I think people are not used to. The fact that like most of the enterprise use cases have like somewhat low tolerance for certain types of errors. And we don't, for instance, in machine learning, have easy ways of like categorizing like critical errors versus other errors and weighting different types. And what like a pretty good, like I was saying this with like, what is, would any of you have a 30% tolerance of flying to the wrong city? And that's like a pretty low risk case, actually, compared to like a lot of, like deployments that we have in finance, in medicine, and in other stuff like that. And what I would consider to be, and again, 70% is like kind of an okay grade in machine learning on balance. 95% is a great grade in machine learning. It's still not a super great grade in a lot of medical contexts. A lot of you would not love a 5% chance of a lot of medical things failing. So I think there's sort of like a lack of understanding there and of collaboration with like the best ways to handle the fact that this is like an inherent property of machine learning, and so you have to build things to accommodate that there will always be, compared to other types of tech advances that the economy has absorbed previously, there will always be a different type of risk of failure than people are used to.
Simon, I'm going to come to you on this. So I'm hearing from you guys a perspective here that I think we don't necessarily always hear when we are being told about how AI might change the world. I'm hearing that on tasks, there might be a failure rate that to the folks in this room would be unacceptable. I mean, frankly, a 95% chance of being taken to the right place by, if I booked a flight would be unacceptable to me as well. That's not the story that we are hearing when it comes to how bullish it feels like industry and frankly the UK government is on its rollout of AI across public services or within industry. Why do you think we've got that gap? And is this something that will be, do you think, fixed over time, or is the idea that we just need to get out there and do it? Why is there this rush, as it were, from where you're sitting?
Yeah, I mean,
Simon, yeah.
So I think one thing to clarify here is that sometimes that last 5% can be solved with a very simple check. Mm-hmm. Sometimes the appropriate check is a human in the loop. Sometimes the appropriate check is like a standard interlock or a standard system. And so if you do look, and so this having an AI solve 95% of it and having this like very basic bit of code solve the last 5%.
Or a human.
Mm-hmm. Yeah. Now all of a sudden you're at 100%. Right. and that's what I mean, like with a bit of innovation, those last 5% could be only solved by model maybe, or maybe only solved by scaffolding, or maybe like could be solved by scaffolding today and will be solved by model tomorrow. But like there are still tasks that are 100%. Mm-hmm. It's just you have to look at the system.
Understood.
And so I think that the real metric that we are seeing is how many are at 100%. And like you end up with this like groundswell of nothing. It can't even like spell words. And then all of a sudden like this, it just starts to just swell up. And I personally just do not see any moment along that swelling up where you cannot take a system and take it to full 100% for most tasks.
So folks who are saying, hey, look, this, it can't even book a flight, well, sure, but it can take you almost all of the way and then finish it off. And suddenly the ramifications of that would be enormous for the economy if suddenly like 80% of every task is automatable or 70% of every task is automatable. Is that what I'm understanding from where we are at currently and how these agents, how these AIs might be being deployed in our economy today or tomorrow?
Yeah, I think it depends on the task, but I think probably the reason it has resonated with the truth that there is behind the hype is that like no person loves reading over like 100 different documents and extracting some data from it and summarizing it for another person, or like doing all of the admin tasks of like changing your schedule when you have to change all of your meetings and other stuff like that. And those sorts of things are like, and again, as Simon says, it's like if you have like verifiable outputs, so like as in presumably if you had an agent that booked you to that changed all of your schedule so that your meetings were in Manchester, you would notice and not accept that. Right. Hopefully. It depends on how you set it up, but like that's part of the system thing of like you have to set up a system that makes that easy to view and correct. But, and so yeah, so I definitely think like there's a huge amount of like these models are going to be very, very, very good at going over an enormous amount of data and extracting important parts of it and presenting it in and there are a huge amount of human tasks that fit into that framework of a task. Mm-hmm. Like extracting huge amounts of data, doing action, or just like relatively closed domain actions, right? Is like one of the, again, I'm going by like, I'm anti-human pessimism. Like a lot of the things that humans are really good at is like extreme generalization. From being able to, like the fact that like presumably a huge amount of people here can like drive and or like ride a bicycle or something along those lines. It's like, and then you can take some of and those are all skills that you've generalized from other motor functions and other, and you also have a lot of cognitive capabilities that way. Like I can tell, people like call it zero shotting, but people like adopt new tasks very, very easily. But there's a lot of tasks that everyone does in their daily life that do not require that, like rearranging your calendar and stuff like that. And little bits of them will, which is why there's only 95%, because there's actually quite a lot of random uniqueness in rescheduling your calendar, but like not that much. And so if you can take a lot of it away, that's quite powerful. I think there is still some truth in there being some things that you cannot actually get to because of the architecture, and this is where it's like, I think anyone who's really way, 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 way too loud on either side of the spectrum, if you're talking about Kautsky or Gary Marcus, is oversimplifying things to some extent. But it's like the angle on the Gary Marcus thing is like that there are architectural things we have built into the way we have made models that mean that they will not be very good at certain things.
Yeah.
like facts is something that that is not how language works. Language is probabilistic. And so like the fact that like there is 100% probability that I am Serafina Goldfarb-Tarrant is like not something they're super great at representing in general. Like, so a language model confusing me with you is like always going to happen to some extent. So there's some things language models I do not think will bubble up and will not become good at, but there's a huge amount of tasks that do not require that.
And it's already very good at.
And it's already very good at those tasks. Yeah.
Thank you. I will spare you the question on whether we should be Yudkowskyites, where if anybody builds it, we will all die, or whether we should be more sanguine. I will turn to the audience now for any questions, and I'll take some of these questions online. We have a lot of interest. If you do have a question, please do put your hand up. Anything on front of the questions that we've tackled today, or on Frontier AI more broadly, I'll come to you. Just let us know who you are and keep it quiet. We'll start over here at the front, and then I'll come around. Hi. Oh, and a mic will be brought to you. Thank you.
Michael Pugh, Chatham House member and lecturer in law at St Mary's University. So naturally, I'm going to ask about regulation and thinking about your title, safety and so on. Is it over-regulated, under-regulated? What do we need in the regulation area?
Great question. Thank you. We'll go just in the middle there. Hi. And then we'll come over to you for one more. We'll take three if that's okay.
Tess Buckley, Program Manager in Digital Ethics AI Safety at Tech UK. Wanted you guys to steer on something keeping me up at night post AI Action Summit, pre-UK-US trade deal, the securitization of safety. We saw that, renaming in safety to security. I'll pause there, but just the kind of rhetoric, semantics, or a shift itself.
Brill, fabulous. And one more question here at the front, and then we'll come back to my panel. Thank you.
Thank you. My name is Paul Lee. I'm at Deloitte, and I do research into technology. So my question is, Serafina, you mentioned LLMs are good at various things. So my question is, what are they good at? And they're better than humans at a lower cost. So what is commercializable, and what is scaling and going beyond a proof of concept?
Thanks, Paul. Okay, so a question there at the end around scaling and what LLMs currently are at least as good as humans are. Question around the sort of securitization of safety. I know the AI Safety Institute, now the AI Security Institute, seeing similar in the US. And a question there about regulation. Maybe in this country, more broadly, are we getting it right? Too much, too little? Yeah, maybe we could start with the regulation question, Serafina, because it does touch on your job title, and then
sure.
I'll come to you.
Yeah, well, as mentioned, as I earlier said, you all probably know more about law than me. Still true. Yeah, from a regulation, but I have talked to, I was talking about the EU AI Act really early, actually, and then a whole bunch of other stuff like that. Yeah, I think it's tricky in that regard. I think something that I don't love about the regulation I have seen is that it's specific in the wrong ways, which maybe is not news to you. I mean, but like the flops thing is dumb. But
so this means basically, to explain to us because it counts how many flops basically, and
yeah.
that is currently the measure being used. Really big model, you can count it using flops.
Yeah,
that's not very good.
Yeah, I've said this too many times, and I lost this battle clearly. But but I mean, basically, you're basically being like, how many steps of math have you done? And then you're regulating based on how many steps of math have you done, and that's not a good way to regulate for a lot of reasons. Again, it's not a law person, but as a tech person, like one of the reasons it's not a great way is that compared to especially the pace of AI nowadays, law is very slow. So you want something that won't be out of date super soon. I mean, the AI Act happened pretty fast, but still, it's still pretty slow. I mean, you end up with lots of I think from previous technology stuff, you have some security standards, at least from back when I worked on, some safety stuff in the United States many, many years ago. There's some weird US laws around coding languages that just mean that government programs don't work very well nowadays because they made a law like way too specific about like what you could do with a browser in like 1980, and like you really don't want to end up with something like that. On the other hand, I do definitely think like there's a significant amount of like the pressure for, as much as, and I work at a frontier lab, right? So like, and I really care about societal harm and stuff like that, but I still definitely do agree that like, I think some, like I think the EUA Act was too specific in certain technical details that are not the right ones, but I do think the fact that they chose to do something is a good idea, specifically for the reason that, you know, we will put, especially when there's a race, we will put resources where there is market pressure to do so. And market pressure is not completely uncorrelated with societal good, but it is definitely not perfectly correlated with societal good. And so to some extent, you need something that fills the gaps that market pressure doesn't have. And even some of the market pressure that exists because of regulation. Like the couple of times that I've been forced contractually, I had actually already done it, but that I've been forced contractually to make a safety implementation was actually because of old regulation around like discrimination law and around like transparency in financial insider trading and stuff like that, right? In these cases, I had actually like usually already implemented something like that because I cared, but like I was glad that I had to. And so that's, and so I think that will always be, there will always be that interplay. And so I think the trick will be around doing it so that it's not so specific as to be as to be out of date too quickly or over much a burden in ways that don't relate to real risk.
So regulation, yes, but perhaps not in the way that we're currently conceptualizing of it. That's and I think that's a very live debate in the UK at the moment, right? Like we've been promised an AI bill. The question is, what will it contain? Simon, can I ask you about the question from Paul around, like, again, sort of capturing what are LLMs capable of? What are they now at a sort of human level? And I suppose an additional question from me: what's baked in? Like, there must be things that are currently live in laboratories like yours that we haven't seen yet. I mean, maybe you can't tell us, but maybe you could at least give us a hint.
So you mean, so the question about how the price of deploying it and running it is more effective is it then? No, that's so. What was the question? Sorry.
It was about applications
Yeah.
which are good enough to be scaled in a commercial environment.
I mean, I would say this is a bit out of my wheelhouse, but
I suppose if you're looking for the next $1 million idea.
I mean, I listed like, so one of the things that like, which does touch on what Simon was saying about like whether you can make up the following 5%. Like, so some amount of this is up to the design of embedding AI into a system, right? But basically, like the things that are good enough are usually things in which someone can verify. Like one of the things that, like I said, like that really changes people's lives is like retrieval and summary of information. So if you're like, what are the 15 emails I got from Chatham House today, and like what are the important things in them, that's good enough because you will know if there's an error, presumably, and your tolerance for error is also probably pretty good. You know, in that like you probably roughly know what sorts of things you'd be emailed about. So if there's a light error in it, then it's kind of okay, and it can save you an enormous amount of time. So I think like, I mean, that's just one example. There's quite a lot because they're general purpose models. But I would say in general, anything in which the human is not seeking new knowledge, but is in some way retrieving and formatting things, because then they can spot if there's an issue. And it's the sort of thing that would take a human actually a really very long time of not a lot of high value stuff.
And it might sound vague, but that does actually describe a huge amount of the jobs that we do.
Yeah.
So.
something that I would love somebody to build is there's this thing called cast analysis, where if an incident occurs, as a human who's like on the ground trying to solve a problem, you try and find the root cause, and then once you've found it, you're like, I'm done, I've done my job, I'm walking away. But there is so much more information that you can get out of, because problems are not trees, they're cycles. Like, so when something goes wrong, it's actually like a cycle in a big system, right? And so there's like causes all through the cycles. Claude, or AI models, can use like these so we have like standard systems safety approaches that are well documented. You follow this approach. Claude can look at every single incident that has like ever happened in your company, and it can like dig in and go like, hey, I'm going to apply this cast analysis approach, and like you can verify that it went through all the steps, because like here is, and it's like, and this has been a way that's like showing, hey, when you do this and you do it rigorously and you do it over the whole system, like you actually start to capture new things, and it's not that you're, and I think the key thing here, that when it's deployed, you deploy it as an extra layer of, here is just something we as a company could have never like found this like weird way in which our company was failing.
Right.
But because we had this thing at scale, like digging into everything that's going wrong, and like extracting the best information out of incidences, and like and using and looking at it from a bigger picture, like all of a sudden you're actually just strictly value adding. It's okay, like if it misses something, it'd be nice if it didn't miss anything, but like it's strictly a plus versus never deploying it.
I'd just like to finish with the question from Tess there around the securitization of safety. This is clearly something, I mean, I think you can take, this question is quite broad. I know that my colleagues at Chatham House have been looking at the sort of growing closeness between some technology firms and departments of defense, but also this sort of some of the rejigs that we've, the AI Safety Institute is now the AI Security Institute. Well, how do you, as the head of AI safety at Cohere, how do you sort of see this? I mean, I hear you're not, I suppose you're not the head of security now, you're still the head of safety.
Yeah, well,
what's happening there?
I mean, I think of it as predominantly geopolitically motivated, right?
In what kind? In what sense?
I mean, I think it's motivated in the sense that a number of things that were previously, I think there's a couple of reasons. I think the reasons that I do not love are the ones where it has to do with a number of the things that were previously under the remit of safety are not as geopolitically popular as they used to be.
Okay, safety is woke.
Yes, exactly. Right. And so the parts that's like not so great is it's a move away from that, and that's like weird because it's not like any of those problems went away. It's not like suddenly we ceased having as much of a problem with misinformation or discrimination or anything along those lines, obviously. But then the part of it that I think is positive is, and I'm genuinely not trying to pull punches with this, is that I think it came with slightly more groundedness in like current problems, and that there had been a view, not always for me, because like I came from a background where I was like, we're doing enterprise deployments, I'm worried about problems that are like literally occurring right now, not something that might hypothetically happen in future. But safety broadly was more like hypothetical future focused previously, and then the rebrand to security frequently made it like unified those two camps of people who were worried about what could happen in future, but also people who were like, no, this is like cybercrime right now or something along those lines. And so I think the downside is the like anti-wokeness, but then the upside is the like more groundedness of some of the previous work.
I'm going to take another round of 3 questions. I'm going to go to start with Emma at the front, and then I'll go there next. Thanks.
Thanks, Emma Ross, Chatham House staff. Can I go back to the realities today and beyond the hype? I'm still not clear. As Alex said, what we hear is this is going to totally upend our lives, transformative. Whether it's in the way medicine works, nobody's going to want to employ us because a robot can do it. That is significant changes to life. What I'm hearing described here isn't anywhere near, doesn't seem to me to be near on the scale of impact on ordinary people's lives. Do we have anything to share about what is the reality or what is hype as to what this is doing now to our lives and the way we as humans exist and live and can expect to earn a living and etc. And maybe you can't future gaze, but where it's going.
Thanks, Emma. We'll just go behind you to the lady in the back row there. I'll take one more here at the front.
Hi, I'm Catherine Elliott. I'm Chief of Staff for a company delivering multi-agent teams to secure enterprises. I wanted to go back to what you guys were saying about error weighting and kind of LLM evaluation. And when we look at it in an agent context, I'd love to get your view on what companies who are providing agents into enterprises should be thinking about when it comes to agent evaluation, mostly from a safety and ethics perspective.
And I think it might be helpful just maybe we'll clarify what we mean by an agentic deployment, because I think it could mean anything, honestly. We'll finish up here if that's okay, and then we'll come back to the crowd.
Foley Hire from Strategic Agenda. We work with some UN agencies and we look at AI and what are their digital policies. To answer your question about what's happening with AI on the ground, how it's affecting people, and also to touch on what you mentioned about translation. Our business began as a translation company 20 or so years ago, and we translated most of the UN's major reports. But what's happened, obviously, with machine translation and now AI, is not necessarily that AI is better than translation, but it's a perception that AI has now solved translation. And I think this is one of the risks of AI. It's a perception issue. So, for example, we have Deloitte asking about how can I commercialize this technology and how can I essentially replace jobs or tasks with AI. And so most companies are now going through that process of thinking which tasks and eventually which humans can I replace with this. And that is the problem, because AI is not quite good enough yet at most things, but it will soon be. But people are already asking that question. I think the second thing also, the other risk is...
I'll ask you to come to a question. I think that's
a sorry.
Comment, but if we're going to...
Sorry. Okay, so the question I had was actually your question, which was what is baked in? What is, what are the models that we aren't seeing? Because, I use Claude 4.5 and it's amazing, but I know they're much more complicated and better models there. So that's another one.
Yeah, you have to tell some secrets. Brilliant, thank you. Well, let's that's a great place to think. So, Emma, to Emma's question, what is reality versus what is hype? We still don't have an answer to that question. A question around agentic deployments, perhaps a little explanation, and Simon might come to you on that. It's like what exactly we mean by an AI agent, and then lastly this question of what's coming down the line.
I mean, I think as far as what's reality and what's hype, I think the two things you're talking about are not mutually exclusive. In that, at least when I think about risk landscapes, a lot of the ways I think of it as similar to like what we did wrong as a tech community with the release of social media. Like not fully, but the reason I'm bringing that up is that I'm like, that changed the world in an enormous amount of ways. Like entire national uprisings like the Arab Spring and stuff happened only because of it. It has changed the way a lot of political systems have worked and stuff like that. And it was also not that fancy. Like, being like, you can post text online, like great, and people have like nice emojis that make people want to engage with them, and it engages some sort of dopamine process in like especially younger humans, but all humans really. And so I mean, and AI is like modern LLMs are much fancier, but that's still changed the world because it changed sort of the way people interact in their daily lives. And I think we have something similar both as far as potential for change and also potential for things to go wrong. But yeah, so like as in like I think it can change the world as far as like commercial, sort of the amount of time that it takes me to look for information in Turkish or something along those lines, definitely. But I mean, I think it will also change things because when it changes the way like, the way that I see like high school students look up information nowadays and that sort of thing is like, it's going to change the world for those sorts of reasons as well. And it doesn't have to be super, super powerful. It just has to be quite good at the stuff it is right now.
Can we have a very brief explanation of what an agentic AI deployment might be? How does that differ? My understanding is it's actually quite similar, but just a longer task. Is that right? How would you explain it, Simon?
Yeah, and before I get to that,
we're going to hear a lot about agentic AI next year, I would assume.
Is to add to that, like it has completely changed what I do and how I work. Like I will be very easily more than 10 times myself, like depending on the task. So in some tasks, I will like grind to a halt and like have to like go at like this very slow pace, and then all of a sudden I step into this new mode and I am running at a very different pace. That's just it.
But it has not very much for what I do, even though we both work in tech. So, but it's partly because for most of the things I do, the cost of verifying whether something is correct is higher than of creating it from scratch.
And so then the question about AI agents. I actually don't like the word agents. Because we've put a construct, we've taken this human concept and we've applied it to these models. When in reality, a single model is able to like copy half of itself across to like another model, and like you can have like, anyway, I will not dig too deep. Essentially, I think what most people say when they mean AI agents is it actually taking actions in the world.
Is it a model that takes an action in the world?
I would think that's what most people are meaning.
So to give us an example from earlier, a model that might book me a flight or book me a table at a restaurant.
Yeah, or autonomously go out and like find people to fish.
Or do something bad, absolutely. December 2026. When are we each going to have access to this technology? When is it going to be something that we have to?
Well, it's back to what I was saying before, in the sense that you have this sort of dual world where there are tasks that can go to 100% because the system is able to be built in a robust way, such that you can trust them, or the task itself it can be trusted to them. And there'll be other tasks where, for whatever reason, it's at 99%, and that 1% really matters. So we are going to have this scenario where like you are just having this rising tide of some tasks being completely automated, and we will start to think of it like ho-hum, and some tasks we'll still be thinking, holy moly, these things are stupid.
Right.
But it will have an absolute, this is just going to keep rising until there is nothing left, in my opinion.
I disagree that there'll be nothing left, but I do think one of the interesting points to add on that, though, as far as like to expand on what you're saying, as far as you were talking about to autonomously go out and find people to fish, is that like that I think people don't talk about that often is that the tolerance for that 5% error or something is going to be different if you're doing something like cybercrime versus if you're not, which means that if you don't have a tolerance for the model potentially misbooking your flight, you might not use it, but someone probably who's trying to use it to fish people probably has a tolerance for it failing a couple of times. And so in a weird way, it like can sometimes can move the needle on malicious activity sometimes faster than on like standard, more boring but more economically helpful enterprise activity, and I don't think people talk about that often.
Can we finish by the first question at front? What's coming down the line? What are you guys brewing back there? Is there something that is baked into current paradigms, scaling paradigms? There is the investment in AI that has already been committed. Chips are being bought, chips are being shipped, the compute is running. What can we expect? What's baked in 2026, 27?
The scaling laws will continue
until morale improves,
and we will do another, and we need to be aligned. We need to have these models. We need to solve alignment too.
I don't think the scaling laws will continue because I was here last time people said that in 2010.
Not continuing. They've been going happy.
They give significantly diminishing returns compared to what they used to. But that doesn't mean that models won't still be getting better. I think they'll just get better for different reasons.
Like what?
Because we'll get smarter about specifically ways we want to train them. We'll get smarter about, like I said, I think like if I'm talking about barriers to interesting types of adoption, I think some of them are capability based, but I think a lot of them are based on like intelligent ways of putting verification in. And that's like not super sexy, but I think that's actually frequently like the next thing that you need to get it somewhere. Yeah, of course, like certain different types of like tool use-based capabilities, you do just need more capable models that can do generalization better. So sort of, it just depends. It depends on whether you want to be able, But I am not a scaling maximalist. Because back when I first worked on machine translation, people were scaling maximalist back then, and they just said you need to shove more of the internet into the model. And back then we were using what we called n-gram models, which nowadays is quite laughable if anyone suggests using them. But you used to also be like shoved off of a stage if you suggested using a different architecture back then, because people just said, no, you need more data.
Right.
And I think it depends on what you want, but more data can't solve all of our problems. It will get us better generalization frequently, but not everything.
I leave this conversation with, I think, this question around risk and risk appetite, and this idea that this technology, which is already extraordinarily powerful, even in contexts where it can't do 100% of the job that we're asking to, but it could perhaps do 95, 96. And this question around, well, how it's actually less about the technology and more the context in which we're going to be deploying these technologies and how our risk appetite to it might change. Perhaps we decide that we want, we are able, we're willing to accept a fail rate of 5% when we apply the AI if it saves us a certain amount of money in a given public service. And I think that the question for the folks in the audience today is to think about, well, let's assume a 95% success rate. Are there contexts where we don't accept that as a potential error? And I think it's clearly, if you look around the world today, there are technologies being deployed in conflict scenarios or in fragile political systems where actually we would expect that fail rate is actually far too high for these to be deployed, but they are being deployed anyway. And actually, it is, while the technologies is in and of itself an important thing, is as important is to say, well, what are you actually asking the technology to do? And that ultimately is a very human question, and a question I think a lot of people here, be it legal, societal, economic, I think are going to face in their day-to-day days. Thank you so much for taking the time to speak with us this afternoon. Can I ask for a round of applause for my audience and citizens? Thank you again for joining us. Please do check the Chatham House website for future events. My understanding is, if for anyone who's got a bit of an interest in the digital and the technical, I think we'll be welcoming the President of Estonia to join us on Monday. So please do come to hear all about how Estonia has transformed its digital services. I think particularly of interest given the announcement that the UK government has made around a potential UK ID system being rolled out. So we'll hear it from the country that many say have done it the best. So I hope we can see you there. Otherwise, see you later on. Thanks, everyone.